Hello, dear engineers and technocrats. In this session, we will learn how to plot R chart and X bar chart. You know R bar chart and X chart are plotted for variable quality characteristics, that is, a quality characteristics which can be measured with the help of instruments, and it will vary as a matter of chance, and it usually follows normal distribution. So before plotting our chart, we take around 20 subgroups, and in each subgroup may contain 4 to 5 items. Such 4 to 5 items, we measure the quality characteristics. Say you take 5 bearing balls and you measure the diameter of each ball. Then this measurement will vary as a matter of chance, and usually it follows normal distribution. So we can find the values of these measurements by using this data analysis solver. We generate a random number. So let's say we generate 5 variables, and around the number of values are say 20. We take the normal distribution, and mean of the ball is let's say 10 mm, and standard deviation is, let's say, it's 1.5. Okay, and we put the output value. We can put here output value, so we select here and press OK. So these values are generated. These are the, let's say, these are the actual measurements when you take 20 subgroups, and each subgroup contain 5 items, and those each item is measured for its quality characteristics, or through measurement you get some values like this. So I can make use of some filter or insert comment format cell, something like that. Okay. So after getting these values, I find out the range. Now for each subgroup, range is the difference between maximum value and minimum value. So what I do, I write here max. So it will return the maximum. So out of these 5 values, it will return maximum value here. Then minus, I take minimum. So this function returns the smallest number in a set of values. So I pick up this again, choose. Okay. So here I get the R value. So here maximum value is 10.85 and minimum is 8.48. Difference is this much. So similarly, I calculate for all the subgroups. Now lower control limit of R bar chart is given by this relationship, that is D3R. So till now we have calculated R values. Now we need to calculate R bar value. So what is R bar? Which is R bar value, and that is the average of all these. So this is what average of all these values, 20 R values, and it comes out 3.68. Clear? So this is R bar value. written here. Now lower control limit of R chart is given by this relationship D3R, and D3 value will depend upon the sample size. Here we have for each subgroup sample size is 5. So corresponding to 5 sample size, the D3 value is 0. So here we put equal to the lower control limit is D3 multiplied by R bar. Okay, and we have to freeze both these values. So we choose select and press F4, right? So here it will take 0 value since D3 value is 0 for sample size 5. Now upper control limit of R chart is given by this relationship, that is D4R, and D4 for sample size 5 is 2.11. So here we calculate this multiplied by R bar. Okay, and we select both and press F4 to freeze it. Okay, okay. This is the value of upper control. Now we select these 3 columns of range, lower control limit of R bar chart and upper control limit of R chart, and insert a line graph. Yes, you got it. So this is your R bar, R chart. This is your R chart, and it is within control, as no point is falling outside the upper control limit. Clear? So this shows your R chart, and this R chart is within control. So this value of R bar, this value can be used for calculating the control limits of X bar chart. If any of the value falls above the upper control limit, then this R chart will not show control, and in that case that value or that observation will be deleted from these 20 subgroups, and we recalculate the R bar value for remaining subgroups till, and we repeat this process till we get a R bar chart in control as shown here. Okay, so once the R bar chart or R chart shows within control, then we proceed further to find the control limits of X bar chart. So now we can find out the X bar value. This is X bar value. Then we find the lower control limit of X bar chart. Then we determine the upper control limit of X bar chart. So X bar value is simply the average of sample quality characteristic. Here we take the average of first subgroup. So this is X bar, and similarly we calculate for remaining subgroups, and it comes out like this. Then we determine the X double bar. Then we determine the X double bar. So here we determine X double bar, D bar, double bar. Okay, so it is what? It is the average of, it is the average of these X bar values. So we determine the average of these 20 values, it comes out this much, 10.15. Now lower control limit of X bar chart, lower control limit of X bar chart is given by this relationship X double bar minus A2R, where A2 corresponding to sample size 5 is 0.58. Okay, so here we determine, so that is X double bar, this one, and this we freeze it as it is a constant value, minus A2, we take this 58 multiplied by this R bar value, and both these are again freezed by pressing F4 key till we get a value. Okay, then we determine the upper control limit of the X bar chart, that is X double bar value, we freeze it plus A2 multiplied by R bar, and we freeze both these values and this one. So upper control limit comes out this much. Okay. Now we plot another chart, that is your X bar chart. So here we select these three columns and we insert a line diagram that is shown here. Okay, I need to make some changes in this, particularly this thing, format axis, so that it start from somewhat 7.5 you get a clear chart like this. Okay, or even I can make I try to make it like from 6 or say 5, so you get a elaborate chart. Okay, so now these are the two charts. This is X bar chart, this is R chart, and both are showing you are getting complete, both the charts are within control, as something has gone wrong here. Okay, so this was the R chart. Okay, so both the charts are within control, as no point is falling above the upper control limit of R bar chart and no point is falling above or below the lower control and upper control limit of X bar chart. So this chart is showing, and so these, once you get such a situation, then these control limits, which are right now trial control limits, these can be used in future and you can treat them as final control limits. Okay. Next is we analyze the effect of the charts. So what we do, we add few groups. Once you have calculated the trial control limits and you have taken these trial control limits as final control limits, since both the charts are within control, in such a situation you can treat trial control limits, final control limits, and you can make use of these limits and for in future for assessing the quality or assessing the process. So now we just add few more, like say again 1, 2, 10. We had 10 subgroups. So this we are going to take in future. Let's say 10 subgroups. Now I again use the same distribution to fit the data say okay. Now instead of 520, I here put 10 only because I am generating 10, and I will insert here. So it will be inserted here. Okay. 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 Now I perform the remaining calculations of R, this thing. These will remain constant. I calculate R bar values. These will remain constant because I am using, and for X bar values are calculated for these things, and these control limits will also remain constant. Okay. Now I extend my these charts for uh, these new subgroups. So how can I extend? I select and I then extract up to. Okay, so this is now showing 30 subgroups. Similarly, I extend these new subgroups in for this chart. So I have extended. You see that both chart are again within control. Why these are controlled? Because my process mean as well as standard deviation is same. Both the standard deviation and mean is same. Now let's make changes and do analysis. So what I do now, you see, and you will be delighted to see what is going on and how the charts are helping you to assess the shift in process mean or shift in process variability or both. So what we do here, let's say first we assess the impact of shift in mean. Now instead of change, my mean earlier was 10, I make it 11. I make it, or you can say 10.5. So my mean has shifted upward. By how much? By 0.5 mm. So now you tell me on which chart will show you the impact of shift in mean. So here you see these new values which I inserted earlier, 26 to 20, this one. These will change. You keep watching these new subgroups written below the 20 from 1 to 10. If I press OK, you will see some change in values. Okay, and based upon these values, has happened? What has happened? Some these R values has changed, right? So still both the charts are okay. We have not plotted a central line. Central line is R bar chart, R value. So I will make a little bit change here in both the charts so that you can understand. Uh, I will add a column here inside, and I will also make here X double bar. So here this value is, let's say, this thing freeze it so that you can get the central line, right? And similarly, we make here x double bar value. X double bar value is this one. So F4, I make use of this, right? Now, when I plot this chart, I make this or you can see how I can increase this. Okay. So now you see this R bar value. Okay. And here again I plot this value and I insert this chart. Oh my, see here and here. Now you can observe the effect. Earlier, since there was no center line, so you were not able to see the effect. You were not able to see the effect. Now you can observe the effect. Okay, so I repeat my experiment. So let's say it was earlier it was 10. I will show how it will appear 10. Here it was appearing 10. So you see all my both the charts are within control. Okay, now I make changes in this. Let's say my process mean has shifted from 10 to 10.5. Okay, so only these 10 observation will change because I am going to find or these values in future as my process mean will shift. So you observe that yes, as far as R bar chart is concerned, it is not showing any impact of shift in mean. But yes, most of the value, earlier the values were falling both the sides of the center line. But right now, what you observe, all of the values are falling above the center line or below the upper control limit. The process is yet not out of control, but this indicates that mean has shifted upward or sooner or later your process may go out of control. Right? Like if I change my process mean from 10.5 to say 11. So earlier it was 10, now it is 11. What is happening? You will observe that all the points, most of the points are falling above the after this 25th subgroup, most of the points, or you let me introduce. Yes, all the readings are there. Okay. Now you see that when my process 11 or you can say again you can change. These are random numbers generated or in 2 or 3 such generations you will get that sometimes the process may really go out of control. Our value changing? Yes, this changing. If you change the process, similarly, if you change the process mean below, means your mean is shifting lower side, say 9, then what will happen? You see that your, yes, R chart is not showing any indication of shift in mean, but only X bar chart is showing that yes, now your processes are going out of it. So this clearly shows when you see the most of the observations either fall on one side of the center line, then you can observe that process mean is trying to shift in that direction. But our chart is not showing any indication of shifting mean. Okay, so we have just uh, changed one variable, that is shift in mean. Now let's say we make changes in standard deviation only. So we keep the mean 10, but we increase first, let's say, decrease standard deviation by 1. Now, any decrease in variation is an indication of improvement in quality. So let's say what happens when our standard deviation has decreased. What you see that on our chart, values are falling, all values are falling below the center line. And here you see that points are falling on both sides of the center line, but they are very close to center line. So you can note that earlier shift in mean was depicted only by X bar chart, right? And if shift is upward direction, the points start falling above the center line. If the shift is downward, points start falling below the center line. Now, when we shift the variability, you see that if the variability decreases, then on our chart, the variability is depicted by both R chart and X bar chart. The point on R chart will start falling below the center line, whereas on X bar chart, the points will fall very near to center line. Now let's analyze the impact of increase in variability. This was we discussed so far was for decrease in variability. Now say let's earlier standard deviation was 1.5, now it becomes 2. What happens? Let's examine. You see here that most of the points now on our chart, most of the points are falling above the central line. And you see here the points are falling on the both side of the X bar chart, but you see they are not falling close to center line, but due to increase in variability, they starts falling close to upper and lower control limits, and sometimes they may fall beyond the control limits. Again, generate random number for same setting. Sometimes you will see that point may go out of the here is R chart is, but here X bar chart is not showing. So that's why we need to monitor both the charts. Both the charts. You can have another experiment, another set of reading for the same setup. You see, right? So you can see what is happening right now, right? So far we have analyzed the impact of shift in mean or increase or decrease in variability. You only observe that whenever there is decrease in variability, that is desirable thing, because point falls below the center line on R chart and they fall very close to center line on X bar chart. So by reducing the variability, we can improve the quality. This is well demonstrated by these two graphs. Now let's say we make changes in both the earlier it was 10 and earlier it was 1.5. Now we make changes in both. Let's say mean is shifting from 10 to 11 and your standard deviation is increasing too. Now what will happen? You will observe. That's it. Yeah. Variability has increased, so point will fall above the central line. And since mean has also shifted upward direction and variability has improved, so point will not fall close to center line. They will fall on both sides of far away from the center line. And since mean has shifted, so most of the points will fall near to or beyond the upper control limit. You can again perform an experiment for the same setting. You will see, yeah, this is the situation, right? So now by doing such experiments on Excel sheet, you can analyze the impact. You not only you can plot and see when the control charts X bar and R, but you can also analyze the impact of change in variability or shift in mean. And before closing today's session, I will conclude now that both R and X bar chart are plotted simultaneously to assess the impact of shift in mean and change in variability. Decrease in variability is desirable and it indicates or it is an indication of quality improvement. Whenever variability decreases, you see that on X bar chart, what will happen? Points will fall on both the sides of the center line, but they will be very close to center line. But on R chart, they will fall below the center line. When variability increases, points will start falling above the center line on R chart, and on X bar chart they may fall on both the sides of the center line, but they will fall far away from the center line and they will fall close or beyond the upper and lower control limits. So this was the impact of variability. Now any change, so change in variability is depicted by both the uh, charts, both R chart as well as X bar chart. Now whenever there is a shift in mean, it is only indicated by X bar chart. If there is a upward shift, then points will fall, most of the points will start falling above the center line, and if the shift is downward, then you will see most of the points falling near to lower control limit. I hope you enjoyed today's session. Thank you for patience hearing.